Hey, what's up my compadres? Today we're going to be wrapping up our look at factoring. This video is designed as a summary of all the things that we've learned throughout the other factoring videos. So if you feel a little bit lost, feel free to go watch the other videos. That may lend you a little bit of clarity. Alright, let's finish this up. Alright, our first example is 10x cubed minus 25x squared minus 15x. The first thing I'm going to notice is that all three of my terms can be divided by a 5 and also an x. When I go to factor that out, I'm left with 2x squared minus 5x, and then last but not least, minus 3. Now from here I'll notice that I can probably factor the trinomial inside the parentheses, so let's try. I'll need two numbers that multiply to 2 and two numbers that multiply to negative 3. When rewriting my answer, I'm going to keep the 5x on the outside of the parentheses because if I forget to write that, I've essentially created a new problem. To get 2x squared, I'll try 2x and x, and to get negative 3, let's try the pair of positive 1 and negative 3. To test the validity of this answer, I'm going to check against my outer and inner products, which together will give me 2x times negative 3 for negative 6x, 1 times x to give me positive x, which combined to give me negative 5x, which I had in my parentheses to start. So my final answer here is 5x times 2x plus 1 times x minus 3. Moving along pretty good here, compadres. Sweet. On to our second example here, we have negative 27x cubed plus 36x squared minus 12x. Just like before, I'll notice that all of my terms can be divided by some common thing. In this case, we're going to call that negative 3x. Now when I go to factor that out, I'm going to be left with 9x squared minus 12x plus 4 on the inside. At this point, I could continue with normal factoring if I wanted to, but I noticed that my first and my last terms are both perfect squares with the 9 and the 4, which means that this could potentially be a perfect square trinomial. So when I go to factor it, I'm going to keep my negative 3x, and then I'm going to try 3x and 3x and 2 and 2 in my parentheses. I now recall that we're going to use the middle term of our trinomial to determine that I need minus signs in the middle of both of my parentheses. And now we're going to use our outer and inner products to determine whether or not this is a valid solution. 3x times negative 2 gives me negative 6x, negative 2 times 3x gives me negative 6x again, and when those combine they give me the negative 12x that I started with in my parentheses, which means that my final answer is going to be negative 3x times 3x minus 2 quantity squared. Hey, this is a lot easier than it seems. And now, my compadres, on to our final factoring example. We have 4x cubed minus 8x squared minus 25x plus 50. In this case, I cannot factor out anything in the beginning, and I also don't have a trinomial, so my normal factoring won't work here. So my only option in this case is to try factoring by grouping, which means that I'm going to put these into two binomials. And what shall we call those two binomials? Why, 4x cubed minus 8x squared and negative 25x plus 50. You can see that our first pair has a 4x squared in common, and this is going to leave us with x minus 2 for our first parentheses term. Our second pair have a negative 25 in common. When we factor that out, once again we're going to be left with x minus 2. Remember, this is a good thing. Since I have x minus 2 here and x minus 2 here, that means that I can factor it out. So my final answer, or so it would seem, will be 4x squared minus 25 times x minus 2. But wait, there's something cool about this 4x squared minus 25. Notice how I have perfect squares in the 4 and the 25. That makes this a difference of squares. What does this mean for us? It means we can factor one more time into 2x plus 5 times 2x minus 5, which means our final answer is all of that times x minus 2. Whew. And there you have it, my compadres, factoring in a nutshell. Feel free to return to this or any of the other previous factoring videos because you're going to need factoring for just about anything and everything else you're going to be doing in math later on. And with that, I'll bid you a good day. See you later, compadres.